One of the challenges of working with chemiluminescence is that you have only one signal to detect, the signal produced by that enzymatic reaction. That can make it a little bit hard to distinguish between targets, especially if they run close together. When targets have molecular weights that are distinct enough, a lot of times they will resort into cutting the membrane in horizontal strips either immediately after the transfer or after the blocking step. That way they can incubate each one of those strips with different primary antibodies. By doing that, they are usually able to reduce the number of non-specific bands and reduce background as well. However, that is not recommended by journals. The principle behind that is that your primary antibody should be specific enough so that you don't have to cut the membrane. If that is not the case, you should go back and optimize your assay conditions to increase antibody specificity, or if you're not able to do that, just change your primary antibody altogether. Another reason why researchers will resort into cutting their membranes into horizontal strips is when they're working with targets that have different abundancy levels. In that scenario, they would be able to expose each one of those strips for different lengths of time, ensuring that they don't have to compromise on sensitivity in order to avoid saturation. However, that is also not recommended because you'd be capturing that enzymatic reaction at different points each time. Instead, try to optimize your protocol so that you can image your entire membrane only one single time. If that is not working for you, perhaps you have to try and use an instrument that has a broader dynamic range, which will allow you to always capture all of your bands despite of how faint or how bright they may be in one unique image every single time. If your targets have the same or similar molecular weight, cutting the membrane is not even an option. In that type of situation, researchers will typically resort to a technique called stripping and reprobing. In that scenario, they will first incubate the membrane, probing for one unique target and acquire the image. Once that is completed, they will incubate the membrane with the stripping buffer, which is a very harsh buffer meant to remove all antibodies from the membrane. At that point, the membrane is ready to be incubated with a second primary antibody, which will probe for their other target of interest. Ideally, during this stripping process, all of the antibodies will be removed from the membrane, both primary and secondary antibodies, but the original proteins will be maintained on the membrane. However, in reality, that is rarely the case. Not only there will be antibodies left over on the membrane, but also proteins will be removed from that membrane. When that happens, the accuracy of the data will be compromised. If you lose the proteins that were on the membrane, when you try and probe for your second target of interest, you will be underestimating how much of that target was really on the membrane. On the other hand, if your primary antibody is not fully removed from that membrane, you may end up overestimating how much of that second target of interest really is on the membrane, since the signal from the first target is still going to be there. On the other hand, that primary antibody remaining on the membrane may also compete with the second primary that you incubate on that membrane. In that situation, you will once again run into underestimating your second target of interest. So that's a lot of variables in there that will compromise data accuracy. And it's very hard to account for all of them. Because of that, we strongly recommend that you do not strip and reprobe your Western blot. Instead of stripping and reprobing your membrane, you may want to consider running each sample in duplicates in one membrane. That way, you can cut your membrane vertically in half and incubate each one of those halves with each primary antibody that you need. That way, you will get to see both targets in one membrane without having to resort to stripping and reprobing. Another alternative may be to switch to near-infrared detection. That way, you can bypass the limitation of having only one signal to detect. If you'd like more information on near-infrared Western blotting, please refer to that course on Lambda U and to the additional resources we have on our webpage. On the next lesson, we're going to be talking about the best practices of how to troubleshoot your chemiluminescent Western blot.